It all started in a small studio, filled with microphones and a soft red light. The Joe Rogan Experience was recording another episode. Joe Rogan runs the most popular podcast in the world. That day, he was talking to Elon Musk about something unusual. "Are you paying attention to 3I Atlas?" "Have you seen the comet?" Joe asked. Elon paused for a moment. "Yeah, I know about it. If I ever find real proof of aliens, I promise I'll come on your show and tell everyone." Joe's continued. "Avi Loeb was here last week. He said this object is made of almost pure nickel, very little iron. And guess what? It just changed its path." Elon looked serious. "If that's true, we have a big problem. If it hits Earth, it could destroy an entire continent. It might even wipe out most of human life within hours." That video clip spread everywhere. Reddit, news channels, social media, everyone was talking about it. This wasn't some made-up story from the internet. Elon Musk himself was saying this could be real. Scientists soon confirmed it. The comet, officially called 3I Atlas, had really changed direction. It was made of pure nickel, the same metal we use in factories. But the strangest part, it was moving in a way that gravity alone couldn't explain. Something else was pushing it, or maybe controlling it. Within a few days, strange things started happening. NASA stopped sharing tracking data. Amateur astronomers were told not to post the comet's location online. The sky suddenly had secrets again. It all began with one simple question on a podcast. What is 3I Atlas? Where did it come from? And why is it changing course? Our planet is always being watched. Not by aliens, but by our own machines. These machines are like digital guards in space. They look for dangerous rocks, asteroids and comets that might come too close to Earth. One of these systems is called Atlas. Its job is simple. Find objects in space and warn us if any are heading toward Earth. It was built to track normal space rocks from our own solar system. The computer programs knew how planets move, how comets fly, and how asteroids spin. Everything followed the same rules. But one night, those rules were broken. The story didn't start with a bright flash in the sky. It started with a tiny dot on a computer screen. A piece of data that didn't make sense. At exactly 2 a.m. Universal Time, a new object appeared. It was just a faint spot of light in the Atlas telescope's camera. The computer saw thousands of such spots every night. It automatically gave this one a name, TLS 2025-2. At first, everything seemed normal, just another space rock to track. The computer noted its position, brightness, and direction. It had done this millions of times before, but then something went wrong. The computer tried to calculate where the object would go next. It tried once, then again and again. The math didn't work. The object's movement didn't match any known pattern. It wasn't following the laws of gravity that control everything in our solar system. The computer was confused. It was like trying to fit a square block into a round hole. The data was correct. The observation was clear. But the answer made no sense. Something was very different about TLS 2025 R2. The quiet, automatic work of the observatory suddenly became urgent. The first warning had arrived. Not with sirens or flashing lights, just a computer program that couldn't finish its task. The problem was its speed. The object was moving at 30 kilometers per second. That is incredibly fast. It is faster than any rocket humanity has ever built. More importantly, it was too fast for an object that belonged to our solar system. Anything born here with our sun would be moving on a slower, more predictable path. Our sun's gravity acts like a leash, keeping everything in a controlled orbit. This object was moving as if it had no leash at all. Its path was also too steep. It wasn't orbiting on the same flat plane as the planets. Instead, it was diving in from above, cutting through our solar system at a sharp angle. It was like a ball thrown from outside a merry-go-round. passing through for a moment before flying off again. The computer checked the data for errors. Maybe the telescope had been shaken. Maybe there was a problem with the camera. But the data was perfect. It was too clean to be a mistake. The signal was faint, but it was steady. Every measurement confirmed the last one. This was not a glitch, it was a real object. And it was behaving in a way that our science had trouble explaining. The computer had no choice but to follow its programming. It had to label what it was seeing. After trying all the normal possibilities, it moved to the next category, a category that was rarely used. It was a label reserved for the truly strange, for the things that did not belong. The system was about to give this object a new name, a name that would alert astronomers all over the world. The computer attached a single word to the object's file. That word was unbound. It is a simple word. But in the world of astronomy, it has a huge meaning. Unbound means the object is not held by our sun's gravity. It is not part of our solar system family. It is just passing through. It is a tourist from another star. With that one word, the object changed from a routine find into a major event. It was no longer just TLS 2025 R2, another rock in a long list of rocks. It was now an interstellar object, an object from the vast, empty space between the stars. This was not just another discovery. It was a message from the deep, a piece of another solar system that had traveled for millions, maybe even billions of years to cross our path. It was a ghost from a faraway place, and it had just appeared in our backyard. The silent alarm had been heard. The computer sent a quiet alert to a handful of astronomers. The message was simple. An unbound object had been detected. The race to understand it had just begun. The sky above us felt a little bigger that night, a little more mysterious. We were not just looking at our own solar system anymore. We were looking at a piece of the entire galaxy, and we had no idea what it was. This was the first warning, that our understanding of the universe was about to change. It was a silent whisper from the cosmos, telling us that we were not alone. As dawn broke over the mountains of Hawaii, the world was still asleep. But in the quiet world of astronomy, a new day had already begun. The first pieces of information about the strange object had started to spread. They traveled not through headlines or television reports, but through secure data networks. They moved as quiet streams of numbers, sent from one observatory to another. The initial alert from the Atlas system in Hawaii was just the beginning. It was a single voice crying out in the digital wilderness. But soon other voices would join in, all around the world. Telescopes were turning their gaze toward a tiny patch of sky. They were looking for a ghost. They were trying to confirm what the first computer had seen. Was it real? Was there truly a visitor from another star system passing through our home? The first few hours of any big discovery are a time of great uncertainty. Scientists are careful. They check their work. They ask their colleagues to check it too. Before they could announce anything to the world, they needed to be absolutely sure. They needed proof from other eyes, from other machines, all pointing at the same spot in the heavens, and all seeing the same impossible thing. The sun was rising, but for these astronomers, the night's work was far from over. A new chapter in our exploration of space was being written, not in a grand library, but in the silent, focused glow of computer monitors in darkened rooms across the planet. The visitor had arrived. Now it was time to get a good look at it. The confirmation came quickly. As the Earth turned, observatories in other parts of the world could now see the same part of the sky. In Chile, high in the Andes Mountains, a powerful telescope finished its scheduled work and turned to the coordinates sent from Hawaii. The operators didn't see a bright new star. They saw exactly what the first report had described. A faint, blurred, but steady trail of light. It was moving just as predicted. The numbers matched perfectly. In Spain, another telescope confirmed the finding. and then another in Australia. Each new observation added another layer of certainty. This was not a mistake. It was not a faulty camera or a piece of space junk tumbling in orbit. Satellites and old rocket parts have known orbits. We know where they are. This object was not on any of those lists. Its path was clean. Its speed was constant. And it was exactly where the calculations said it would be. It was moving at a speed that was simply too fast. For anything born in our solar system, an object from our neighborhood would be moving in a gentle, curving path, forever tied to the sun. This object was moving in a nearly straight line, a cosmic bullet piercing through our home. It was on a journey that started somewhere else, in a place we couldn't even imagine, and soon it would be gone again, continuing its journey back into the deep dark. We had only a short time to study it. The quiet confirmation from telescopes around the globe was the starting gun in a race against time. Once enough evidence was gathered, the information was sent to a special group. This group is called the Minor Planet Center. It is the official record keeper for all the small objects in our solar system. They are the ones who track asteroids and comets. They give them their official names. When they received the data on this new object, they followed their usual process. They checked the numbers. They verified the observations, and then they issued a notice. But this was not a loud announcement. There were no press conferences or dramatic images. It was just a quiet bulletin, a simple electronic message, sent out to the global community of astronomers. The bulletin was technical. It was filled with numbers and coordinates, but to those who knew how to read it, its message was one of the most exciting in years. It simply stated that an interstellar object had been confirmed. Our solar system had a visitor from beyond. There was no speculation about what it was. There was no talk of aliens or spaceships. It was just a statement of fact delivered in the calm, careful language of science. To the rest of the world, nothing had changed. But for a small group of people who watched the skies, everything had changed. They had just been told that a piece of another world was flying past our front door. The universe had just sent us a postcard. The object was given an official name. It was called 3I Atlas. The I stood for interstellar, and the number 3 was perhaps the most important part of its name. It meant that this was only the third such object ever discovered. The first was a strange, cigar-shaped object called Oumuamua, which had passed by in 2017. The second was a more comet-like object named Borisov. And now there was a third. This new discovery was exciting, but it also raised a quiet and slightly unsettling question. We had found this object by accident. The Atlas system was not even designed to look for such things. It just happened to stumble upon it. So, if we found this one purely by chance, how many others have passed by without us ever knowing? For centuries, we have looked up at the stars and felt like we were on an island, separated from the rest of the universe by huge, empty oceans of space. But now, we were beginning to understand that the ocean was not so empty. Things were crossing it. Pieces from other islands, other star systems were floating by. We had just been blind to them. The discovery of 3 Atlas was like finding a new footprint on a deserted beach. It was proof that we were not as isolated as we thought. The universe was a busy place full of travelers, and we had just met the newest one. The question was no longer if we would ever see a visitor from another star. The question was, what would the next one be like? And how many more were on their way? An interstellar object does not arrive with a big show. There is no bright flash, no thundering sound. It appears as numbers. It is a quiet whisper in the data, a faint signal pulled from the noise of the cosmos. For the first 12 hours after its discovery, only a small network of automated telescopes knew that 3I Atlas even existed. These were machines, not people. They logged its position, measured its light, and sent the information to other machines. It was a cold, digital process. The human element, The sense of wonder and excitement would come later. For now, it was just a problem to be solved, and the problem was getting harder with every passing minute. The object was already very faint. It was far away, and it wasn't reflecting much sunlight. As it continued on its path through our solar system, its brightness was quickly slipping away. It was like a fading ghost. Astronomers knew they had a very small amount of time to study it. They had a window of just a few days. After that, the object would move too close to the sun. From our point of view, it would be lost in the bright glare of our own star. It would be like trying to spot a firefly next to a searchlight. The chance to learn its secrets would be gone, perhaps forever. The clock was ticking. The race had begun. This sense of urgency spread quickly through the astronomy community. All around the world, observatories had to change their plans. These big telescopes are very busy. Their time is scheduled months, sometimes years in advance. Scientists compete for just a few precious hours of observation time. To interrupt that schedule is a very big deal. But this was different. This was a visitor from another star. It was a once-in-a-generation opportunity. So special requests started flooding in. Astronomers were asking, even begging, for a little bit of time to point their telescopes at this faint, fading star. They were queuing up, hoping to get a quick look before it vanished. The operators of these giant machines, the people who actually run the telescopes, work through exhaustion. They stayed up all night, carefully guiding these massive instruments. They would finish one scientist's planned observation. Then in the few minutes before the next one began, they would quickly point the telescope at the coordinates for 3I Atlas. They would take a short picture, a quick snapshot of the traveler. They were stitching together these short exposures, trying to build a clearer picture of what it was. It was difficult, stressful work, but everyone knew how important it was. They were chasing a shadow, and they couldn't afford to let it get away. The tools they were using were not designed for this kind of chase. The tracking systems at most observatories are built to follow asteroids. Asteroids from our own solar system move at predictable speeds. They follow paths that are well understood. 3I Atlas was different. It was moving much faster. The software had to be pushed to its limits to keep up. It was like trying to take a picture of a speeding race car, with a camera designed for taking portraits. The results were often blurry and imperfect, but they were real. Each new image, no matter how faint, was another piece of the puzzle. The first results were minimal. They were not beautiful, colorful pictures of space. They were grainy black and white images. On them, 3I Atlas was just a faint smudge of light, a tiny dot moving against a backdrop of distant stars. But that tiny dot was moving at 30 kilometers per second. It was moving exactly as the first calculations had predicted. Every single observation confirmed the computer's first whisper. It was unbound. It was coming in from the dark, and it was leaving just as quickly. It did not belong to us. The evidence was building. The ghost was real, and the more astronomers looked at it, the stranger it seemed. The initial excitement of the discovery was slowly being replaced by a deeper sense of mystery. What was this thing, and where did it come from? The more they looked, the less they understood. The chase was on, but the object itself remained a deep enigma. Scientists had hoped that by gathering more light, they could figure out what it was made of, or at least get a better idea of its shape and size. But the object was not cooperating. It was just a point of light, a fading echo in the dark. The data they collected was full of strange little quirks, things that didn't quite add up. Its brightness changed in odd ways. Its path had a tiny, almost unnoticeable wobble. These were small details, but in science, small details can be the most important things. They can be the clues that lead to a huge discovery. For the teams working around the clock, frustration began to mix with the thrill of the chase. They had found a visitor from another star, but it was refusing to tell them its story. It was a locked box and they couldn't find the key, but they didn't give up. They kept watching. They kept collecting every precious photon of light that traveled across the solar system. From this mysterious stranger, they knew that somewhere in that faint light, there was an answer. They just had to be clever enough to find it. The race to track 3I Atlas was more than just a scientific challenge. It was a test of human curiosity and our relentless desire to understand the universe around us. And the universe was presenting us with one of its greatest puzzles. Yet once the news of 3I Atlas became public, the race against time became a global effort. It was no longer just a few specialized observatories. Now, telescopes all over the world joined the hunt. In the high, dry air of the Canary Islands, giant mirrors turned towards the object. In the remote mountains of Chile, astronomers canceled their dinner plans to get more data. In Japan, robotic telescopes were reprogrammed to track the visitor. As it moved across the night sky, it became a friendly competition. Each team wanted to be the one to gather the best information. Before 3I Atlas moved too deep into the sun's blinding glare, every photon of light collected was precious. A photon is the smallest possible particle of light. To these scientists, each one was like a piece of currency, a tiny bit of value they could use to buy knowledge. They were collecting these photons one by one, from an object that was trillions of kilometers away. It was an incredible task. The raw images that came from the telescopes were not impressive. They were thin and looked almost empty. 3I Atlas appeared as a faint, featureless smudge, like a speck of dust on a black piece of paper. To an untrained eye, it would look like nothing at all. But to the astronomers, these faint smudges held the first clues to a very big mystery. The real magic happened when these images were combined. The scientists used a technique called stacking. Imagine you're in a very dark room, and you want to take a picture of a tiny, dim light. A single photo might not show anything, but if you take 100 photos and layer them on top of each other, the faint light will start to appear. The signal gets stronger, while the random background noise gets averaged out. This is what the astronomers did with 3I Atlas. They took dozens, sometimes hundreds of these faint, dusty-looking images and stacked them together in a computer. As they did, the signal became clearer. The faint smudge became a more defined point of light, and within that light, they started to see something. They could see structure. It wasn't just a simple dot. It had a shape, a form that they could begin to study. This process took hours of careful work. Every image had to be perfectly aligned, but the result was worth it. For the first time, they were seeing 3I Atlas not just as a point of data, but as a real object. It was a physical thing with its own unique properties, and one of those properties was very strange indeed. It was a clue that suggested this was not just a simple rock tumbling through space. As they looked at the stacked images, astronomers noticed something about the object's brightness. It was not constant. It seemed to pulse, getting a little brighter, then a little dimmer, then brighter again. This is normal for asteroids and comets. As they tumble through space, they show different sides to us. A flat, wide side will reflect more sunlight and look brighter. A narrow, thin side will reflect less light and look dimmer. But the pulsing from 3I Atlas was different. It was happening in a very specific rhythm. The pattern was too regular. It was too predictable. It was as if the object was turning in a very controlled way. This was the first major clue that something was unusual. A normal rock, broken off from a larger body, would be expected to tumble randomly. It would spin and wobble on multiple axes, like a poorly thrown football. But 3I Atlas seemed to be rotating smoothly, like a perfectly balanced top. Its brightness changed in a clean, repeating cycle. This suggested that 3I Atlas wasn't just a randomly shaped chunk of rock. Its regular pulse of light hinted at a specific shape. It suggested a kind of symmetry. Maybe it was long and thin, or flat like a pancake. Whatever its shape was, its rotation was surprisingly stable. A single detail, the rhythm of its light, began to change how scientists thought about the object. It also changed how they planned to study it. At first, the main goal was just to confirm its path and get a basic idea of what it was. But now, they had a specific puzzle to solve. Why was it spinning so perfectly? What could cause an object that had traveled between stars for millions of years to have such a stable, controlled rotation? This was not the behavior of a typical comet. The scientific teams adjusted their plans. They started using different kinds of filters on their telescopes, trying to measure the changes in its light with even greater precision. They needed more data on this strange pulse. They needed to map it out to understand its exact timing. The mystery of 3I Atlas was deepening. It had already broken the rules by being an interstellar visitor. Now it was breaking the rules of how such an object should behave. It was no longer just a rock. It was a rock with a secret, and that secret was hidden in the faint, rhythmic whisper of its reflected light. The first strange clues had been found. They pointed to an object that was more complex, and perhaps more interesting, than anyone had first imagined. The story was just beginning. When scientists first plotted the measurements of 3I Atlas, its path mostly made sense. It was moving on a trajectory that was expected. For an interstellar object, it was a long, sweeping curve shaped by the massive gravity of our sun. The sun was pulling it in, bending its path, and would eventually fling it back out into deep space. On the big picture level, everything looked correct. But as they looked closer at the smaller details, things started to get confusing. One of the biggest puzzles was the way its brightness changed. That regular, rhythmic pulse of light didn't seem to match its expected spin. The object was turning, but the way the light reflected off its surface suggested a shape, or a motion that was hard to explain with simple physics. 3I Atlas appeared to be a natural object, a piece of rock and ice from another star system, but it was moving in a way that seemed unnaturally controlled. It was a contradiction, a paradox that sat at the heart of the data. It looked like nature, but it acted like a machine. This was a deep puzzle, and scientists knew they had to solve it. The answers would tell them if this was just a strange, new type of comet or something else entirely. Usually, when a comet behaves in a strange way, there is a simple explanation. As a comet gets closer to the sun, the ice on its surface heats up. That ice turns directly into gas, a process called sublimation. This gas shoots out from the comet in jets. These jets act like tiny rocket engines. If the gas shoots out from one side of the comet, it will push the comet in the opposite direction. This can change its speed and its spin. This is a very common thing to see with comets from our own solar system. It's what gives them their beautiful tails of gas and dust. So the first idea was that 3I Atlas was doing the same thing. Maybe gas jets were pushing it around, causing its strange motion and its controlled spin. It was a good theory. It was the simplest explanation, but there was a very big problem with it. When astronomers looked closely at 3I Atlas, they couldn't see any gas. They couldn't see any dust. The object was not shedding any visible material at all. Their spectral readings, which he used to find the chemical makeup of objects, were coming back flat and sterile. There were no signs of water, gas, or carbon dioxide gas coming off of it, even though they were watching it with some of the most powerful telescopes on Earth. The most obvious explanation for its movement was completely wrong. The mystery was not just its brightness or its spin. It was the object's apparent control over its own movement. It was moving through space, with a kind of purpose that was difficult to explain. This LED scientists at labs like NASA's Jet Propulsion Laboratory, or JPL, to do a very careful analysis of its path. These are the world's experts on calculating orbits. They can predict where a spacecraft will be years from now, with incredible accuracy. When they applied their powerful computer models to 3I Atlas, they found something remarkable. They confirmed that the object was experiencing a non-gravitational acceleration. This is a very technical term, but it means something simple. The object was being pushed by a force other than gravity, and it wasn't just being pushed by the gentle pressure of sunlight, which can affect very small objects. This was a slow, steady push away from its predicted path. It was a tiny deviation, but it was constant, and it could not be explained by any known natural process. It was as if a ghost was gently nudging it off course. It was an unseen force acting on this visitor from another star. The data was clear. The object was accelerating on its own. This strange behavior was not entirely new. It was, in fact, strangely similar to what astronomers had seen with Oumuamua, the first interstellar visitor, which had been discovered 8 years earlier. Oumuamua had also shown a small, unexplained acceleration. It had also failed to show any visible signs of gas or dust. At the time, the discovery had caused a huge debate among scientists. Some had argued it must be a new kind of natural object, perhaps a comet made of frozen hydrogen. Others, like the Harvard astronomer Avi Loeb, had suggested a more radical idea. They had proposed that Oumuamua's strange acceleration could be explained if it was a very thin, artificial object being pushed by sunlight like a solar sail. Now, history seemed to be repeating itself. Another visitor had arrived, and it was breaking the same rules. Scientists were very careful with their words. They avoided using terms like propulsion or maneuver. They stuck to the technical language of non-gravitational acceleration. But in the private emails and quiet conversations between researchers, the implications were clear. 2 visitors had now shown up from other stars, and both of them had broken the known rules of physics. It was either an incredible coincidence, or it was a sign that our understanding of the universe was about to be turned upside down. The unseen force was real. The only question was, what was causing it? After the telescopes had taken as many pictures as they could, they moved on to a different technique. This technique is called spectroscopy. It is one of the most powerful tools in astronomy. It works by taking the light from an object and splitting it into its different colors, like a rainbow. But it's more than just a pretty picture. Within that rainbow of light, there are tiny dark or bright lines. These lines are like chemical fingerprints. Each element, like hydrogen or oxygen or iron, creates its own unique pattern of lines. By studying these lines, astronomers can figure out exactly what an object is made of, even if it is trillions of kilometers away. The goal for the Atlas was simple. If it wasn't a typical comet, then what was it? Was it a strange kind of asteroid? Was it made of rock, or metal, or something else entirely? Spectroscopy was supposed to give them the answer. It was supposed to read the object's barcode and tell them its story. The teams pointed their powerful spectrographs at the faint point of light. They let the light build up for hours, gathering every possible photon. Everyone was waiting for the results. They were hoping for a breakthrough, for a clear fingerprint that would solve the mystery. But the ghost in the sky was not ready to give up its secrets. When the first spectra came back, the scientists who saw them were stunned into silence. The graphs were almost entirely blank. A spectrum is usually shown as a line on a graph. The line goes up and down, with sharp peaks and deep valleys that show the different chemical fingerprints. But the spectrum from 3I Atlas was just a quiet, gentle slope. There were no peaks. There were no valleys. There were no clear chemical signs of any kind. It was as if the object was a perfect mirror, reflecting sunlight without adding any information of its own. It was not bright enough, or chemically active enough to reveal what it was made of. This was deeply frustrating. All the effort, all the hours of telescope time had resulted in a blank page. A normal comet, when heated by the sun, shows very clear signs in its spectrum. You can see the fingerprints of things like cyanides, carbons, and water vapor as the sunlight excites the gas around it. 3i Atlas showed none of that. It was completely, strangely silent. The message it sent back to Earth was empty. Its light offered no clues. It was a ghost reflection, a perfect echo of sunlight with no personality of its own. This silence was not just an absence of information. To the scientists, it felt like an act of defiance. The object was supposed to tell them what it was. That is what comets and asteroids do. They bleed gas. They shed dust. They leave a trail of clues behind them. But 3i Atlas was different. It was clean. It was sterile. Even when they tried again, with longer exposures, and using different kinds of filters on their instruments, the story didn't change. The spectrum remained mute. The blank graphs were a confirmation of what the images had already suggested. There were no gas jets or dust clouds around the object. This meant that the theory of sublimation, of gas pushing the object, was almost certainly wrong. If there was gas, the spectrograms would have seen it. The evidence was simply not there. So now they had two major contradictions. The object was accelerating as if it were being pushed by gas jets. But there was no gas. It was a comet that refused to release gas. That is a contradiction in terms. It's like talking about a fire that gives off no heat. It moves like a comet, but it acts like a stone. The scientists were stumped. They started coming up with new theories to explain the silent spectrum. Maybe the object was covered in a thick crust of carbon-rich material, like a layer of soot. This crust could be trapping all the ice and gas underneath, preventing it from escaping. Or maybe it was made of exotic kinds of ices, things that we don't normally see in our solar system, which would only turn to gas at much higher temperatures. These were interesting ideas, but none of them fit the data perfectly. A sooty crust would make the object look very dark and reddish. But 3i Atlas was more neutral in color. An exotic ice would need to explain the acceleration, which was still a problem. Frustration grew in the scientific community. The faint trace of light that should have told them the object's story was instead erasing it. For every question they answered, two more appeared. The ghost reflection was a perfect mask. It showed them nothing, and in doing so, it told them everything. It told them that this object was unlike anything they had ever seen before. The mystery was deeper than they could have imagined, and their best tools were failing them. The strange data coming from 3i Atlas was like a fork in the road for the scientific community. The puzzling information, especially the silent spectrum and the unexplained acceleration, caused scientists to split into different groups. Each group looked at the exact same numbers, the same graphs and the same images, but they came to very different conclusions. This is normal in science. When a new mystery appears, there are often many different ideas about how to solve it, but the disagreement over 3i Atlas felt deeper. It was more intense. It was a sign of a growing unease, feeling that this object was challenging the very foundations of what they thought they knew. The two sides of the argument were not angry with each other. They were respectful colleagues, but they saw the universe in two very different ways, and 3i Atlas was forcing them to confront those differences head-on. The debate was about more than just one strange object. It was about how science should respond when faced with something that seems to break all the rules. It was a quiet intellectual battle for the future of astronomy. One side of the argument urged for patience and caution. This group was made up of many experienced mainstream astronomers. They argued that there was no need to jump to extraordinary conclusions. They believed that a natural explanation must exist. We just hadn't found it yet. They said that we needed more observations and better computer models. They pointed out that our understanding of comets is still incomplete. Maybe there are strange types of comets in other star systems that behave in ways we have never seen before. 3I Atlas, they argued, was not a crisis, it was an opportunity. It was a chance to learn something new, to improve our theories about how comets work. They believed that, with enough time and enough data, the puzzle would eventually be solved. They cautioned their colleagues against speculation. Talking about things that were not supported by hard evidence was dangerous. It could damage the credibility of their entire field. To this group, 3I Atlas was just an anomaly, a strange data point. It was not proof of anything beyond the fact that the universe is a very weird and wonderful place. They believed that the simplest explanation is usually the right one. And the simplest explanation was that this was a natural object behaving in a natural, if unusual, way. The other side of the argument saw the same evidence, and felt a growing sense of alarm. This group saw a pattern. They remembered the strange story of Oumuamua from 8 years before. They saw the same small, smooth acceleration. They saw the same lack of any visible gas or dust. They looked at the inferred shape of 3I Atlas, which seemed to be long and thin or very flat, and it all felt uncomfortably familiar to this group. Seeing the same set of strange properties in a second interstellar visitor was not a coincidence. It was a message. It was a sign that something fundamental was being missed. They argued that to pretend this was just another normal comet was to ignore the evidence. It was like seeing a fish climbing a tree and insisting that it must be a strange kind of squirrel. They felt that their colleagues were being too conservative, too afraid to consider new ideas. At Harvard, a private memo began to circulate among a small group of researchers. The memo carefully compared the path of 3I Atlas to the path of Oumuamua. It pointed out the stunning similarities. The memo didn't use any dramatic words. It was written in the dry, technical language of science, but its conclusion was explosive. It suggested a reevaluation of current cometary dynamics. This was a polite way of saying that our current theories about comets were failing. That quiet academic memo was never meant for the public, but somehow a copy was leaked to a journalist. The key sentence, the one about reevaluating our theories, was underlined in red. The story exploded. It sparked 1,000 cautious statements from scientists and universities around the world. The author of the memo never mentioned aliens or extraterrestrial technology, but the implication was clear enough to cause a huge stir. The idea that these objects might not be natural was now out in the open. NASA and the European Space Agency, ESA, quickly put out official statements. They tried to calm everyone down. They reaffirmed their belief in natural explanations. They said that 3I Atlas was a wonderful chance to improve our scientific models. They made it clear that curiosity was good, but wild speculation was not. Publicly, the scientific community tried to present a united front. They wanted to show the world that they were in control, that this was just a normal scientific process. Behind the scenes, however, the emails and online forums were much less unified. Researchers argued late into the night over the meaning of the data. The word propulsion was never said aloud in official meetings, but it hovered in every silence between the replies. The growing unease was real. 2 interstellar visitors had now broken the same rulebook in less than a decade. The unofficial truth was that a good explanation did not exist yet, and no one wanted to be the first to stand up and admit it. Science was facing a mystery that it could not easily solve. By the second week of observation, a new problem had emerged. 3I Atlas was becoming too faint to see. As it continued on its path, it was moving further away from Earth, and it was getting closer to the sun in the sky. For telescopes on the ground, The mission was becoming almost impossible. The faint light of the object was being swallowed by the growing brightness of the twilight sky. The window of opportunity was closing fast. The last hope for getting more information rested with the instruments that were not on Earth at all. The last hope was with the telescopes that were already in space. These space-based observatories orbit high above our planet's atmosphere. This gives them a much clearer view of the universe. They don't have to worry about clouds or city lights, or the blurring effect of the air. But even for them, this would be a difficult task. These telescopes are powerful, but they are also busy with their own missions and their own schedules. Pointing them at a new, unexpected target would take a special effort. It would require clever planning and a little bit of luck. The hunt for 3I Atlas was moving to a new arena, the cold, empty void of space itself. The first attempt came from a very unlikely source. The European Space Agency had a spacecraft called the Trace Gas Orbiter, or TGO, which was in orbit around Mars. Its main job was to study the Martian atmosphere, looking for tiny amounts of gases like methane. It was not designed to be a telescope for looking at distant objects, but it did have a powerful camera on board. The camera was called Cassis. It was built for taking detailed, colorful pictures of the surface of Mars. It was not built for tracking fast-moving, faint objects against the blackness of space. But the mission team was determined to try in October of 2025. In a brave and creative move, the engineers reprogrammed Cassis. They were going to try and find 3I Atlas from Mars orbit. It was a long shot. No one was sure if it would work. The camera was not designed for this. The software was not designed for this. But they had to try. It was one of the last chances to get a new look at the mysterious visitor before it was gone for good. The team worked for days, writing new code and planning the observation. It was a high-risk, high-reward mission. The biggest problem was that Cassis couldn't track a moving object directly. Its system was designed to point at a fixed spot on Mars below, so the engineers had to invent a completely new method of observing. They called it the step and hope method. They would point the camera at the spot where they predicted 3I Atlas would be. They would take a short exposure. Then they would quickly shift the camera's view just a little bit to the next predicted position. They would take another picture. They repeated this process over and over, creating a series of images that they hoped would catch the object as it moved. The result of this technique was not a sharp, clear picture. Instead, it was an intentional blur. If they were successful, 3I Atlas would appear as a gray streak, a faint line drawn across the field of stars. To the public, an image like that would probably look like a mistake, a technical failure, but to the scientists, that blurry streak would be a huge success. It would be proof. It would be confirmation that the light from 3I Atlas had been captured at the right coordinates, at the right time, from a spacecraft orbiting another planet. It was a testament to human ingenuity. The commands were sent across millions of kilometers of space from Earth to Mars. The TGO spacecraft received its new instructions and turned its camera away from the red planet and towards the deep black. It performed the step and hope maneuver perfectly, and then the long wait began. The data had to travel all the way back to Earth. When the first blurry images finally came back, they looked almost like abstract art. They were a series of grainy, gray frames, but on one of them, there it was, a faint, smudged streak. It was exactly what they had hoped to see. The smudge was weak, but it was there. And when the scientists looked very closely at that smudge, they saw something incredible. The streak was not uniform. It showed structure. The leading edge of the streak, the part that corresponded to the front of the object, appeared to be slightly sharper and brighter than the tail. This tiny detail hinted at symmetry. It hinted at a controlled rotation. The ghost was not just a smudge. It had a shape. A few days later, another great observatory joined the hunt. The Hubble Space Telescope, orbiting Earth, was pointed at 3I Atlas. Its own images were also blurry, because the object was so faint and moving so fast. But they were consistent. Hubble confirmed what Cassis had seen. The visitor was still there, and it was still hiding its secrets in plain sight. The blurry streaks of light from the Cassis camera and the Hubble Space Telescope were not beautiful images. They would never end up on posters or in magazines. But to the scientists who studied them, they were some of the most important pictures ever taken. A special group of imaging analysts began to compare the blurry streaks from the two different telescopes. They looked at them pixel by pixel. They were searching for hidden patterns, for tiny clues buried in the noise. They were forensic scientists, examining the scene of a cosmic event, and they found something. They noticed that the brightness shift between the leading and trailing ends of the streak was not random. It repeated itself, and it repeated at very regular intervals. They could measure the time between the pulses of light, and that timing was incredibly precise. The pattern was too clear, too uniform to be ignored. It was a signal. It was a message written in the language of light and motion, and it told them something profound about the nature of 3I Atlas. It told them that this object was rotating on a fixed axis. It was spinning like a perfectly made wheel. This was a stunning discovery. Most comets and asteroids in our solar system do not spin like this. They tumble as they get warmed by the sun. Gas jets erupt from their surfaces at random points. These jets push the object, making it wobble and spin irregularly. A typical comet's rotation is messy, chaotic, and unpredictable. But 3I Atlas was the complete opposite. Its rotation was constant, smooth, and deliberate. It was as if it were perfectly balanced, even as it was flying through our solar system. At 30 kilometers per second, it maintained this impossible spin. It was a feat of celestial mechanics that defied all natural explanations. How could a piece of rock, after traveling through the turbulent space between stars for millions of years, achieve such a perfect state of balance? It was a question that had no easy answer. The data was whispering a quiet truth. Its perfect motion hinted at an absence of natural forces. It suggested a level of control that was not born from chaos, but from order. Natural objects are messy. They are shaped by collisions and random forces. They are imperfect. 3I Atlas, in its motion, was perfect. To most people, these images wouldn't look exciting at all. They were just faint lines of light drawn across the darkness of space. They were technical data, not art. But within those lines, a new story was emerging. A story that was even stranger than the one they had been telling so far. The object's perfect spin was another piece of evidence that did not fit the natural explanation. First, there was its unexplained acceleration. Then there was its silent spectrum with no signs of gas. And now there was this impossible, perfect rotation. Each new piece of data made the puzzle harder to solve, not easier. The universe was showing them an object that behaved as if it was engineered. It was an object moving perfectly through a universe that could no longer predict its behavior based on natural laws alone. The blur was coming into focus, and the picture it was revealing was one that made many scientists deeply uncomfortable. They were looking at something that should not exist. The spinning was a clue. It was a piece of the puzzle that pointed towards a conclusion that was once unthinkable. The visitor was not just a rock. It was something more. The first prediction for the orbit of 3I Atlas only lasted for about a week. After scientists collected more data, they had to issue a new one. The second prediction didn't last much longer. Every new measurement, every new observation from a telescope forced an update to the object's path. The official databases struggled to keep up. They were constantly rewriting history. By the middle of October 2025, the Minor Planet Center had issued 5 separate notices. Each one corrected the object's trajectory, its brightness, and its spin data. This created a strange situation, a kind of paradox. The more data they collected, and the more accurate their numbers became, the less stable the story seemed to be. Usually in science, more information leads to more certainty, but with 3I Atlas, more information was leading to more confusion. The object was simply refusing to behave as expected. It was a moving target, not just in the sky, but in their computer models as well. The history of its journey was being rewritten day by day, and each new version of the story was stranger than the last. Corrections like these are a normal part of space science. When a new object is discovered, the first orbital calculations are just estimates. As more data comes in, those estimates get better and better. But the edits for 3I Atlas carried a deep sense of unease with them. They were not small tweaks. They were fundamental changes. If you looked at the official data logs, you would see the computer notes next to a line that said, "Fit improved," meaning the new model was a better match for the observations. There would be another note. This note would say unexplained offsets. These were small but consistent differences. Between the predicted path and the actual path, the object was always a little bit off from where it was supposed to be. These were tiny deviations, but they were always in the same direction. The object was drifting. It was stubbornly refusing to follow the clean, predictable path that gravity had laid out for it. It was forging its own path through our solar system. The analysts at the European Space Operations Center, or ESOC, decided to combine all the data into one massive new model. They took the information from the ground-based telescopes. They added the blurry images from Cassis around Mars. They included the data from the Hubble Space Telescope. They put it all together into what they called Revision 2.1. This new improved model was the most accurate picture yet of the object's journey. It did help to reduce some of the strange anomalies. Some of the unexplained offsets got a little smaller, but it did not make them disappear. Even in this best-fit model, 3I Atlas still drifted slightly, off a purely gravitational path, and the team still had no good explanation for it. The gas venting theory, the idea that it was a comet shooting out jets of gas, still had no proof. The spectrum was still silent. There was no evidence of any gas. For every correction they made to the orbit, another mystery seemed to appear. Scientists proposed other ideas. Maybe the object was being pushed by something called thermal recoil. This is when one side of an object gets heated by the sun, and then re-radiates that heat, creating a tiny push. But the numbers didn't quite work for that either. Maybe there were small, systematic errors in the data from all the different telescopes, but that seemed unlikely. The idea that dozens of different instruments, all over the world and in space, were all making the same mistake was hard to believe. No theory seemed to satisfy everyone. The more precisely the teams tried to define 3I Atlas, the more it seemed to blur under the weight of their own statistical certainty. Publicly, the orbit looked neat and clean. In the diagram shown on the news, 3I Atlas followed a smooth, beautiful curve through the solar system, but privately. In the data logs and the technical notes, the story was much messier. The logs showed just how little anyone truly understood. They were a record of the struggle, of the constant corrections and the lingering questions. The official line that was sent out in the bulletins read, "Orbit solution refined." It sounded so confident, so scientific, but to the people who were actually working on the problem, that phrase felt less like a statement of fact and more like a confession. It was a confession of their own uncertainty. They were refining the orbit, yes, but they were no closer to understanding the object itself. Its history kept changing because its present was a complete mystery. It was a ghost in the machine, an object that was there but could not be pinned down. The more they learned, the more they realized they didn't know. The rewritten history of Three-Eyed Atlas was a story of science, working at its limits, faced with a visitor that seemed determined to keep its secrets. At this late stage of the chase, Three-Eyed Atlas was still technically in the sky, but it was now incredibly faint. It was a barely traceable whisper of light, very difficult to observe. The easy part of the mission was over. Now came the hard work. Each new attempt to take a picture of it required much longer exposures. The telescopes had to stare at one point in the sky for hours, just to collect enough light to see anything at all. It also required extremely precise timing. The object was still moving fast, and they had to predict its position perfectly, to even have a chance of catching it. On the raw images that came back from the telescopes, the object was almost invisible. It was completely lost in the random noise of the digital camera. Scientists had to use their stacking technique again, combining many of these long exposure images together. Only then could they lift its faint signal out of the background noise. What was once a clear streak of light across the stars had now become a soft, uncertain trace. It was a smudge of doubt in a sea of black. The object was still there, but the effort to prove it was still there grew heavier with every night of observation. The universe seemed to be reclaiming its secrets. For a few short weeks, it had offered a glimpse of this strange visitor. Now it was slowly pulling a curtain of darkness back over it. Most of the smaller telescopes had already given up. Their operators sent messages to the larger facilities, officially handing over their tracking requests. The hunt was now in the hands of only the most powerful observatories on the planet. The apparent brightness of Three-Eye Atlas was now at the very limits of what could be seen from Earth. It was pushing the boundaries of our technology. Only the giants like the Gemini North Telescope in Hawaii and the observatory at Mount Loa were still reporting successful detections, and even these were on the very edge of what is statistically certain. Every new confirmation was not a simple picture. It was a complex piece of data analysis. Every potential detection needed layers of computer processing to verify it. The scientists had to carefully check that the faint smudge was not just a random fluctuation of noise or a cosmic ray hitting the detector, or some other kind of error. They had to prove, beyond a reasonable doubt, that they were still seeing the ghost. Yet through all of this difficulty, one thing remained consistent. The object, as faint as it was, continued to move exactly where the strange, revised orbital models predicted it would be. Its earlier strange behavior, the non-gravitational acceleration, was still part of its path. There were no new irregularities. There were no sudden changes in its course. It was just a slow, steady fading of measurable precision. The object was following the strange rules it had established for itself. The faint light that they could still capture was also consistent. It still reflected cleanly. The spectrum, as weak as it was, still showed no signs of dust or gas to cloud it. The object was clean. It was silent. It was disappearing with the same mysterious grace with which it had arrived. What had changed was not the object itself, but our ability to see it clearly. A scientist on the team described it perfectly. He said the signal-to-silence ratio had changed. At the beginning, the signal from 3E Atlas was loud and clear. Now, the silence of space was much louder. Each new photon they captured felt borrowed. It was as if the universe was slowly taking back the little evidence it had offered. The vanishing evidence was a sign that the time for observation was coming to an end. Soon, the story of 3-Eye Atlas would move from the telescopes to the textbooks. It would become a legend, a famous mystery. But there was one more secret, one final incredible twist yet to be revealed. The story of Three-Eye Atlas was about to change, in a way that no one could have predicted. While astronomers were focused on its fading light and its strange orbit, another group of scientists was looking at a different kind of data. They were studying the telemetry from the object. Telemetry is a general term for all the information an object sends out, not just visible light. It includes radio waves and other invisible signals. For a natural object like a comet, this is usually just random noise, the faint crackle of energy from the sun reflecting off its surface. At first, the radio signals associated with Three-Eye Atlas were dismissed as exactly that, just noise. But as the object got fainter in visible light, something strange started to happen in the radio spectrum. The signals, which had been random, started to show a rhythm. There was a pattern emerging from the static. A team that was using a large radio telescope to listen to the object found that the signals were not just random static. They were structured. They were deliberate. They were complex. While the astronomers were arguing over orbital equations, they found that the telemetry from Three-Eye Atlas read more like coordination than random motion. It was as if the object was not just a passive rock, but an active transmitter. This discovery was a turning point. It presented a stark choice. Either these structured rhythmic signals were some new, completely unknown natural event, which would mean our understanding of physics might be wrong, or they were artificial. The patterns were too complex, too repetitive to be a coincidence. They had all the hallmarks of a signal designed to carry information. This was a moment of quiet, profound shock for the researchers who found it. They checked their data again and again, looking for any possible error in their equipment. But the signal was real. It was coming from the exact position of Three-Eye Atlas, and it was unlike anything they had ever heard from space before. The implications were enormous. The scientific community had been focused on whether the object was a strange comet or something else. Now, they were faced with the possibility that it was not just an object, but a probe, a messenger. The debate over its acceleration and its spin suddenly seemed like a minor detail. The real story was in the signals it was sending. It was a story that humanity was never prepared for. The news was kept secret for weeks. The information was shared with only the highest levels of government and the military. This was not something to be released to the public without careful thought. But eventually, the secret could not be held. In a press conference that was broadcast around the world, a group of sober-faced NASA officials made an announcement that would forever change human history. They announced that they had been receiving complex, structured transmissions from the interstellar object Three-Eye Atlas. And then they delivered the bombshell. They said that after weeks of intense work with linguists, mathematicians, and cryptographers, they had decoded the message. This announcement shocked the world. It was the moment that humanity had dreamed of, and perhaps feared for centuries. It confirmed that the object was not a natural rock. It was something else entirely. It was an artifact of an intelligent civilization. The contents of the decoded message itself were kept secret at first, the officials said. They needed more time to fully understand its meaning and its implications. But the mere fact of its existence was earth-shattering. It was the first, undeniable proof of intelligent activity from beyond our solar system. The implication was clear, and it echoed in every corner of the globe. We were no longer alone, and something, or someone, was trying to communicate. The discovery launched the story of Three-Eye Atlas into a completely new chapter. The object was no longer a scientific curiosity. It was now a matter of global importance. It was the single most significant event in human history. The questions were immediate and overwhelming. Who sent it? Why did they send it? What did the message say? The world held its breath, waiting for answers. The silent, fading visitor from the void had finally spoken, and its voice was about to change our world forever. The quiet search for knowledge in the dark had led to a revelation that was brighter than any star. The universe was not empty and silent. It was full of intelligence, and it had just said hello. The news of a decoded message from an interstellar object sent shockwaves across the globe. It was not a slow, creeping realization. It was a sudden, violent shift in our understanding of reality. In a single moment, the world we thought we knew was gone, replaced by a new, much larger, and far more mysterious one. The impact was immediate and profound. It touched every aspect of human life, from science and religion to politics and art. The story was on every news channel, on every website, in every language. For the first time in history, the entire human race was focused on a single event. We were all looking up at the same sky, but now we were seeing it with new eyes. The stars no longer looked like distant, cold points of light. They looked like potential homes. The universe was no longer a vast, empty space. It was a neighborhood, and we had just learned that we had neighbors. The implications were staggering. It was the beginning of a new chapter for humanity. In the world of science, the news caused a revolution. Entire fields of study had to rethink their most basic ideas. Astronomers who had spent their lives studying planets and stars now had to consider the possibility of artificial objects and interstellar travel. Physicists had to grapple with the technology that could power such a journey. And biologists had to confront the undeniable proof that life, an intelligent life, exists beyond Earth. The very foundations of our scientific understanding of the universe were shaken. It was as if we had been studying a single grain of sand, and someone had just shown us the entire beach. The message confirmed that we were not a unique accident. Life was not a miracle that had happened only once on our small blue planet. It was something that could happen elsewhere. This discovery challenged our philosophical and religious views. For centuries, many human belief systems had placed our species at the center of creation. Now, we had to confront our true role in a much larger cosmos. We were not the center of the universe. We were just one small part of a much bigger, more complex story. This was a humbling realization, but it was also an incredibly exciting one. Governments and international bodies began holding urgent meetings, secret meetings. They had to discuss the implications of this new reality. What did this mean for national security? What did it mean for the global economy? How should humanity respond? These were questions that no leader had ever had to face before. The public reaction was a mixture of every possible emotion. There was awe and wonder at the scale of the discovery. There was excitement about the possibility of learning from a more advanced civilization. But there was also fear and uncertainty. Who were these beings? Were they friendly? What did they want? News channels around the world played the story on a continuous loop. Experts were brought in to analyze every possible meaning. Scientists became global celebrities overnight. Everyone had a theory. Everyone had an opinion. The scientific community itself rapidly shifted its focus. The goal was no longer to simply observe 3-Eye Atlas. The new goal was to understand its sender and its purpose. The message was the most important piece of data ever collected, and the work of deciphering its full meaning had just begun. This event was immediately seen as one of an elite few of the most important moments in human history. It was on the same level as the discovery of fire, the invention of agriculture, or the first step on the moon. The message from 3-Eye Atlas, though its full content was still a secret, had created a new reality for every single person on Earth. We were now a species with cosmic company. Nothing would ever be the same again. With the confirmation that a message had been decoded, the immediate and most important question became, how do we respond? Or perhaps more importantly, should we respond at all? This question sparked a fierce global debate. On one side, There were those who argued that we had a moral obligation to answer. It would be a sign of our own intelligence and our peaceful intentions. It would be the next great step in our journey of exploration. On the other side, there were those who urged extreme caution. They argued that responding would be like shouting into a dark forest, without knowing what might be listening. We knew nothing about the civilization that sent this probe, contacting an unknown and,